Hello and welcome to Technology Computer Class. Today's topic is Mars Rover Landing 2021. Our goal is you will learn about the Mars Rover Perseverance, which will land February 18th, 2021, and also learn the facts behind this historic event. You will then code your own Mars Rover to explore Mars. Some terms to keep in mind: sol, not the soul with your body, but a solar day as measured on the planet Mars, which is equal to 24.65 hours. So that is basically a full rotation of Mars, as just like we spend our days as 24 hours, but a Mars full rotation is just a little bit more, which is 24.65 hours. Another word you're going to come across is autonomous, so able to operate with little or no human control or intervention. So we are going to learn about this Mars rover, and thanks to Mars Rover, we have the next video.
If you look right behind me, you'll see the center of the universe. And the reason it's called the center of the universe is because that's NASA's Jet Propulsion Laboratory. And all of the orbiters, probes, and spacecraft we've sent out into the solar system and beyond send all their signals right back here to be processed. And that will never be more apparent than in a few days when the next Mars rover named Perseverance concludes its 7-month journey to our neighboring red planet Mars, autonomously navigating itself for a terrifying 7 minutes, traveling from 15 times the speed of a bullet to a gentle 3 miles per hour touchdown, all while live streaming the key data the whole way down. And as many of you know, for me, this is like coming home, because long before I started making YouTube videos, I came here to work every day for 9 years, 7 of which were working on the last rover we sent to Mars named Curiosity. So today we're going to talk to some of my old friends and see the actual rover up close as I bring you up to speed on everything you need to know about this rover landing. Because once you have an overview of what's going to happen and what it even took to get us to this point, I feel certain you're going to feel just as pumped about this historic landing as I am. And to accomplish that, we're going to talk about the who, what, why, where, and how of this rover. And we'll start with the why and the where we're going. 3.5 billion years ago, Earth and Mars were pretty similar. Both had liquid water at the surface, and both were protected from the sun's radiation with magnetic fields. And so it begs the question, if life first developed on Earth at that time, could it have also developed on Mars? So this is a massive lake in Jezero crater billions of years ago. And this is it now. This is where Perseverance is landing, the bottom of an ancient lake the size of Lake Tahoe, because using Earth as a guide, at the base of a river of fresh water is where scientists believe we have the best chance of finding evidence of past biological life on Mars. So thanks to Perseverance, we could be on the verge of the monumental first discovery of actual life outside our planet. And being able to pinpoint a landing spot this tight shows how NASA is constantly advancing its technologies. With Florida for scale, here's an oval showing the uncertainty of the landing spot for previous missions: Pathfinder in 1997, and then Phoenix in 2008, Curiosity in 2012, and now Perseverance. Being able to shrink down a landing target just gives you way more options of interesting places to land. Plus, once you do land and start driving towards the actual science location, it could shave off a year or more of drive time. And not only does studying Mars like this help us understand Earth's past and future, but the rovers we're sending are the advanced scouts, taking data and notes for us on the ground and sending all the info back to Earth. They're also testing some new technologies, which I'll cover in a second, that humans will need to use when we're exploring the planet ourselves in the very near future. Because the first person to set foot on Mars is alive right now. And it could be you. And if none of that gets your heart pumping, and you're like, but Mark, why would we spend resources and time exploring the solar system when we still have big issues here on this Earth we haven't solved? I tackled that exact question, giving 5 reasons we can't afford not to invest in space in another video you can watch after this one. So that's the where and the why. Now let's talk about how we're going to do all that, because this is where it gets really wild. Meet Perseverance. And I should mention, I have my monthly videos all planned out about a year in advance, which is why exactly this time last year, I knew for this video I needed to fly down to check out the rover right before it got shipped off to Florida to be launched. But before I checked out the rover, I first stopped in to see Ben, who was my old boss. When I was here, he was leading a small team that designed the jetpack that lowered the rover to the ground. But now I heard he's all fancy, in charge of like 400 people, so I wanted to get a sense of how things had changed for him. So anyone we see walk by, you can like boss them around? About this guy right here. You can boss him around?
Yeah, I can boss him around.
Okay, cool. Go on. We first geeked out for a bit over a bunch of examples of parts from previous space missions, and a hardware wall like this is just a great illustration of what makes JPL such a cool place to work. Actually, I designed this. This is my hardware from Grail with Andy. This was cool because you got these like flexures for like temperature variation. So this isn't just for show. This is like literally when you're trying to figure out a way to do things. These are examples of how it's been done before, right?
Right, and a lot of these are made by examples of this is the way you shouldn't do it.
Oh, so that's why my hardware.
That's why your hardware's up there, right?
And so after that, we headed down to check out the rover and meet up with my friend Emily. But before we could just go in and see it, we had to get suited up because the rover is looking for signs of biological life, and we don't want to contaminate our samples before we even arrive. So a bunny suit and air shower can go a long way. Emily, by the way, was the vehicle assembly lead for the descent and cruise stages, which is a big responsibility. This is the rover.
The flight rover. It will be on Mars 12 months from now.
It's so complex when you come up and get this close. In fact, Perseverance is the most complex thing humans have ever built and sent to another planet. It's got laser, X-ray, and radar capabilities, plus 19 cameras, and a nuclear-powered battery system for energy. And while it might look pretty similar to the past rover Curiosity, all the science instruments are completely different because the science objectives have changed. The most notable difference is this time the drill isn't there just to create rock dust to study on the rover. Perseverance has a hollow drill bit to core out a chunk of rock the size of a piece of chalk and then package it up and leave behind 43 separate samples for a future mission to collect and send back to Earth. That way we could study the samples for those past signs of life using the most state-of-the-art instruments on Earth that we could never fit on a rover. So then to capture that chalk-sized rock sample, not only is there an arm on the outside, but this time there's one on the inside too.
It is a miniature robot arm inside the body of the rover that manipulates the sample tube, and there's one right here.
Wow. And so is this what you leave behind?
Exactly.
Is it fair to say this is like the poop of the rover?
Exactly.
Okay. Do you like that analogy? Because they didn't like it earlier.
Well, yeah.
You like it? Okay, cool.
We do like to say that the rover is going to poop out samples.
Okay, good. See, that's a good analogy. So Perseverance is really only the first leg of returning a piece of Mars to Earth. Future missions will complete what I like to call the poop, scoop, and shoot maneuver. This is my friend Liz, by the way, and she's in charge of all the testing for the sample retrieval system.
We're doing things that nobody else does, so we have to test it.
So she tests all sorts of different configurations in a chamber that recreates the extreme temperatures and pressures to make sure it will function on Mars. Because once you send something to space, it's gone, and you can't exactly fix it, so it just has to work, which is why testing is such a big deal here at JPL. My buddy Matt here mentioned another way this is done.
We build two spacecraft, one that goes to Mars and one that we keep here on Earth to test. And this is an exact replica of Curiosity, who's driving around on Mars right now. And then we use this one to test driving around obstacles and driving over rocks.
And he knows a thing or two about driving over rocks because he was a rover driver for both Opportunity and Curiosity. This guy is like one of maybe 40 people in the world who has driven a vehicle on another planet, which is it's kind of a big deal. And so a few more cool things about Perseverance are that it has a mini helicopter drone stowed away on its underbelly named Ingenuity. This will be mankind's first powered flight on another planet, which sort of makes this a Wright brothers moment. And the rover and the drone will get great footage of each other, but we're mainly testing it out so that in the future we might use drones to scout out terrain for us or get samples from hard to reach locations, or you could have swarms of drones carrying materials for humans from one site to another. Perseverance is also testing out a new instrument called MOXIE that basically amounts to a mechanical tree because its function is to convert CO2 into oxygen, which future explorers will need to breathe and for rocket fuel.
The rover has been in this clean room for about a year and a half, starting as just a chassis, just the skeleton.
And then all the teams and engineers have been taking turns coming down and building up their part until it's done. In fact, I was in that exact position on Curiosity, designing my hardware for about 3.5 years, and when it was all tested and complete, integrating it on the rover right here in this room. And then for the other 3.5 years, like I mentioned before, I was working with Ben on a small team of engineers on the jetpack descent stage. So now we've covered the where and the why we're going, also the how we're gonna do all that with the rover. Now let's talk about the what, for what's gonna happen this Thursday when it lands and what you should expect to see. As I edit this video, the spacecraft is gliding toward Mars at a cool 48,144 miles per hour. How fast is that? It's this fast. It's 15 times faster than a bullet. It's traveling the length of 100 soccer fields in exactly this long. And it will keep on that trajectory until...
Okay, maybe you missed it. I'm going to go ahead and play this again. But just to give you an idea of how fast this is traveling, any of you guys go ahead and raise your hand quietly. Any of you guys play soccer, football? Okay, put those hands up. Soccer, football? All right, go and put them down. So imagine you're on a really long road, or put yourself in a mind. Line up 100 of those soccer fields. Okay, line them up all in a row. How far can you see? That's pretty far, right? Okay, 100 soccer fields in this amount of time. Okay, make sure you're paying attention. You might miss it.
How fast is that? It's this fast. It's 15 times faster than a bullet. It's traveling the length of 100 soccer fields in exactly this long. And it will keep on that trajectory.
That's insane. That is so fast. Incredible. All right, let's continue.
Until the big moment on Thursday when it starts its entry, descent, and landing, or EDL. It's also known as the 7 minutes of tear because we've literally got 7 minutes to get from the top of the atmosphere to the surface of Mars, going from 13,000 miles per hour to 0 in perfect sequence and perfect timing, and the spacecraft has to do it all on its own with no help from us on Earth. When it first hits the upper atmosphere, the friction causes the heat shield to start glowing like the surface of the sun, all the while thrusters are firing to steer and adjust its course towards the target location. And that aerobraking gets rid of 99% of the energy, so for the last 1%, we deploy a supersonic parachute. Then we've got to pop off the heat shield we no longer need, like removing a lens cap, so the radar can start viewing the ground. But even with the parachute, it's still traveling 200 miles per hour, which is way too fast to land. And so that's where we cut loose of the back shell and fire the rockets. But we can't quite land in this configuration because the rockets will kick up too much debris and damage the rover. So then we lower it from a 21-foot rope and gently land the rover on the surface as my sky crane zooms off to face an honorable, catastrophic ending as far away from the rover as its remaining fuel will carry it. And so in just 7 minutes, the spacecraft has completely metamorphosized, shedding all its sacrificial elements until you're left with just a rover sitting alone, safely on the surface of Mars. Now, everything you just saw was a CGI animation, but a few days after landing, we'll all be blown away by actual HD landing footage from the 23 cameras and 2 microphones on board. We'll see the parachute inflate and hear the crunch of the aluminum wheels as they touch down and make contact with the Martian surface. And because Mars is so far away, to get a signal from the vehicle to our planet, it takes about 12 minutes at the speed of light. So that means after the spacecraft sends a signal that it's reached the top of the atmosphere, by the time that signal reaches Earth to kick off the 7 minutes of tear, for at least 5 minutes, the vehicle has actually already been on the surface, either alive or dead. Which is why it has to be autonomous. That means it makes all its own choices on the exact timing of things and where to steer without anyone from Earth controlling it. Which means all we can do is watch and monitor and hope. And this is a good time to remember that as easy as these dedicated teams of engineers make it look, landing on Mars is really hard. Historically, only about half the attempts have been successful, but the willingness to take big risks to reap big rewards is the foundation on which NASA is built. The live stream to watch the landing starts on Thursday, February 18th at 11:15 a.m. Pacific. It will hit the top of the atmosphere an hour and a half later at 12:48 p.m., which starts the 7 minutes of tear, and we touch down at 12:55. I will leave a link to the live stream in the video description, as well as some other really cool sites, such as this video game-like demo where you can interactively experience the 7 minutes of tear in preparation for the landing. We covered the where and the why we're going, we covered the how with the rover, and the what with the landing details. Now, it's time for the who, the human side to sending robot explorers to other planets. What makes NASA and JPL really great aren't its robots, it's the people who build them. And while it's not really possible for me to capture what it's going to feel like for them to see it land this Thursday, the best I can do is to show you what it felt like for me 8 years ago when I was in a very similar situation.
All right, and feel free to watch the rest of that video. It's his testimony about being part of the NASA team to be able to help build the last rover called Curiosity. So fascinating stuff. So we're going to dive into our activity now. And so if you are looking here, we have watched our introductory video. And now, depending on what grade you're in, this is going to be some of the activities that you get to do. So if you are in grades 3 and above, you're not going to be doing the number 1 activity first. You're going to be actually doing step number 2, game number 2. So the first one, though, if you are in kindergarten through 2nd grade, this is called Mars Rover. And I'm going to walk you through some of this. And so there are going to be ads on this website, unfortunately. So I'm going to go ahead and click play. Don't need to sign in. And this is simply, you're going to be scouring the terrain of Mars, but you're going to need to try to keep your robot stable. So if you're on a phone or a tablet, this works great because then you can put your thumb here, and then use this balance tool. So you're going to be driving and you're going to be collecting samples. You have to be careful because you can damage your wheel pretty easily. Okay? And if you go too fast, you could end up damaging your wheel. Okay? So the trick is to be able to keep going, and you may need to try to balance. Take it slow, but if you go too slow, you're going to get this little red zone here, and it'll be game over. So this is just a chance to have a little fun, especially kindergarten through second grade. You can try this out. And then that's going to be for them. Now, for the grades 3 and above, this is where I want you to start, is game number 2, Mars Rover Programming. And click on this one. And this one may take about 30 to 40 seconds to load, so just have some patience with that. All right, now that the game has loaded, if you don't see the word begin on yours and it says continue, go ahead and click reset progress. This is because if there's a student on the computer before you, it may save some of that. So if it says continue, just click reset progress, and then you should see the begin button. We're not going to be doing free play. That's something that you can do at home or on your own time. But today we're going to be doing the activities. And so let's go ahead and learn about this activity. On your screen, it may look better if you want to do full screen. On mine, it kind of distorted some of the text, so I'm going to keep it like this. Rover Coder. It can take over half an hour for a signal to get from Earth to Mars and back again. That means NASA has to program its rovers to act as independently as possible, sending them commands, then waiting to see how it turned out. Each set of instructions will take 1 Mars day or a sol to execute. How fast can you complete the missions? All right, so this is very interesting. I really do enjoy this activity. So available rover commands are here. We'll start with simple commands and give you more powerful ones as you progress. Rover deployment. Drag the forward tiles to get out of the landing area and reach the marker. So you can see that it's measured by sol. They're saying it's the Mars rotation for a day, but really the way that it keeps track is this is your number of tries or attempts. Basically, whenever you click the start button, it kind of keeps track, and it goes dark, it dims for a whole day idea. So I'm going to go ahead and click got it, and then try it. Drag 5 go forward commands into the empty slots below. So, and notice that it says 2 meters. The distance measurement tool doesn't necessarily matter, but let's go ahead and do some math here. If I have 5 groups of 2 meters, how many meters is that total? Go ahead and show me with your fingers up in the air. How many do you think it is? 5 groups of 2 meters. That's right. It's going to be 10 meters total. You could do 5 times 2 or flip it over, 2 times 5. Looks good. Tap start to send the instructions to the rover. So we're going to give this a try. And you're reaching the green destination marker. And this is just like the in the NASA Control Center. All right, this is awesome. Okay, way to go. You're out of the landing area and the rover is ready to explore the Martian surface. You completed the level in 1 sol using 5 commands. Can't do much better than that. So this is where I really would like you to check this out. This says, here's the first panoramic image taken after the Curiosity rover landed on Mars in 2012. So I'm going to go ahead and click more info. Fantastic. This 360-degree image is made up of 130 images taken during Curiosity's first 2 weeks on Mars. The mountain is Mount Sharp, about 12 miles away. So this is the mountain. It's about 12 miles away. So what you need to understand about a 360-degree image is if you were to take a panorama, like if you're on a phone and you take a panoramic view, it's basically if you stood in a circle and you turned around 360 degrees. So you just did a whole full circle around. So what they did is they took pictures, and think of a high-quality camera zoomed in pretty far, and it captures this section. So let's just say this is one picture image, and then this is the next second, third, fourth, fifth images here, and you got about 130 images all slapped together or pasted together to create one composite image. Fantastic. Just beautiful stuff, okay? All right, next level. And then this is a turn left, so counterclockwise command by default. It will turn the rover by 45 degrees. You can check what a command does in more detail by tapping it. Got it. So right here, this activity focuses really on the engineering design process, about you're trying to design a way you're going to try different things out, and then you're going to test it and see how it works. And if it doesn't work out, you got to figure out, well, what went wrong and that kind of thing. So right away, if I go ahead, for example, go ahead and put in 4 meters there, rotate 45, and then notice the number gets lower. And then I'm going to keep moving and see what happens. And I'm going to go ahead and click start, even if I use them all. Yeah, let's go ahead and use them all. Notice that the green highlights for the step of code that I gave it. So it does 45 degrees. And it continues for 2 meters. And you're going to see, oh, did I make it? Not exactly. Okay, so I need to do some different codes to be able to get to it. So notice that it spent 2 days on Mars, so 2 sols, and I still didn't make it to the rock, but technically I should have if I put that 45 degrees first. So keep that in mind while you're testing it out. So you're going to have to readjust for the next movement, because just like in NASA, they put in a command, well, you're stuck where you put it. And so this one's going to be testing it out, try it out, see what happens, okay? All right, so that is step 1 of the programming. If you go down to step 3, it has the Mars Rover Programming 2. So this is for grades 3 through 8. And this is the, I would say, more advanced one. And this is called Explore Mars. Send sequences of commands to Mars Rover. Collect as much data as possible in 8 expeditions. So right away they're teaching you need to drag your object in to the slot. Again, I said this is more of an advanced thing, because you're going to want to be able to move the rover and then also search for the object. So right away, I'm going to go ahead and put that arrow there, and it's going to tell me how long do I want to, how long do I want to move. So go a little further, I'm going to bring it back. So this arrow, the end of the arrow is actually where it stops. So when I put it at 4, I actually overshot the distance. So then I have to confirm it by clicking move 3 units.
Keep an eye on the drawn path to keep track of where the rover will go.
And then I'm going to go ahead and tell it to do 45.
The rover to rotate.
So you can do a whole 90 degrees. Click confirm. And then I'm going to use the move forward. This is move backward. This is move forward. And then I'm going to have to tell how far it is. 0. No, I want to move it to this point right here. And then I'm going to say move 2 units. And then I'm going to have it search so I get the extra bonus points for finding it.
Find some good data here.
And I'm going to go ahead and click. And my commands are moving down here. Now it's analyzing.
You've collected some great data. Be proud.
Great. So
Very efficient use of commands. I'm impressed.
So you can finish each round. You can go to a rock and not collect any information, but you're not going to get your bonus points on that. One cool little thing here is you can do view area, so you can basically plan ahead. Where do you want to go? What's going on? And basically you just need to go to each of these rocks and have that search object on there. And based on where you end up on each of your turns is going to impact your next code sequence, and you can click go for that. So I say a little more advanced, but if you did the first activity, this should be a lot easier. This one is one of my favorite. It's the Perseverance simulation. And so this was mentioned actually in Mark Rober's video, and I stumbled across it coincidentally even after seeing his video. If I just paid attention, I would have seen it. But this is really awesome because this is the entry, descent, and landing. And how you do this, you can use your mouse or your trackpad and you can zoom in to look at this cool details. This is what's going on. Over here at the left bottom, you have the stages. What's going on? How fast? How many miles is it from? How fast is it going? So velocity, it's going 10,000 miles an hour. Okay, so a little on the fast side here. And it's doing a D-spin cycle. But here's the neat part is you can speed this process up. So you don't need to wait the 15 minutes. You could sit and watch this whole thing, but I'm going to go ahead and click on this area here and then use my wheel and scroll down. Notice that it sped it up, okay? And I am now counting down closer. So the lower the number, touchdown is getting closer. So cruise balance. So at each step, you can learn a little bit more about what's happening. Okay, so I'm going to zoom out so you can get a better picture. So I'm going to speed this up. And you can start seeing some of the heat come in because it's got the friction. Knowing that when you come into an atmosphere or into Mars with a somewhat of an atmosphere, it has air friction. If you've ever stuck your head out in a car and it was kind of hard on your face or hard to breathe, that kind of thing, that's the air friction. And if you go fast enough, it can heat things up. And so now it was looking a little bit toasty back there. Now it's into its cycle. Now in here, you're going to go ahead and see the parachute pop out. So I'm going to zoom out just a little bit here. Here it goes. This thing is huge. Okay, remember this capsule thing is bigger than a car. Okay, you can fit the rover inside. So this thing is huge. And you can see that we're coming in at an angle. So this thing is coming in pretty fast still. We're still at 370 miles an hour. Okay. And then I'm going to go ahead and keep speeding it up. And then you can get down to the point. Yep, there it loses it. It's parachute. It comes down for landing. Talked about in that simulation video. Oops. And then the next step, descent stage. There it goes, dropping the cord. Angles are actually kind of hard to do here. There we go. And we have touchdown. Very cool. And there is Perseverance. So the rest of the resources below are places where you can watch it live, or at this point, maybe be able to watch the feed if it's already been passed. And there are some other resources listed here as well. So like a step-by-step breakdown of what actually is happening, what time it's going to occur, that kind of thing. So for the rest of the class, obviously, if you're in grades 3 through 8, these are definitely for you. Kindergarten through 2nd, this is yours. And then any place, I totally encourage you guys to watch it if you haven't. If it's already past the date, I highly encourage watching a piece of history happening during your lifetime. So it's really, really exciting, really kind of cool, because this is going to be data that can actually in the future be sent back back to Earth. So it's going to be our first time collecting something from Mars that's coming back to Earth. Now, we've done the moon, but that's a lot closer than Mars. Just remember that this spaceship has been traveling for about 7 months. 7 months. That's a long time. And with that, have fun.